everybody, Miss Mokano here, and I wanted to make a little video tutorial to discuss how we write hypotheses, and also it's going to be a little bit of review of independent and dependent variables as well as control variables. So getting right into it, let's write down, this is an assignment that you guys either have already worked on or will work on. So I want to just kind of go through it, and so let's right off the bat, let's kind of remember what an independent and a dependent variable is. So IV, abbreviation for independent variable, is the variable that we are purposely changing or manipulating in an experiment. The dependent variable, also abbreviated as DV, is the variable that we measure. It's basically the effect, the variable that we measure to assess the effect of the independent variable. And you'll see how this plays out as we go through the next few examples. And controlled variables are basically all variables that are kept constant or the same during the experiment. All right, so let's see what this actually means with some real example. So example number 1, does the amount of time 4th graders spend watching TV affect their reading scores? So the first thing I would do before I even jump into hypothesis, first thing I would do here is identify the independent variable. So the independent variable is the variable, like we said above, that we are purposely changing in this experiment to see what effect it has. So what are we purposely changing in the experiment? We are purposely changing this amount of time that the 4th graders spend watching TV. So I'm going to put that in this orange color, and I know that is my independent variable. How about, or you can just write it here, amount of time. How about the dependent variable? So I am purposely watching the amount of time that 4th graders spend watching TV because I want to assess the effect of that on their reading scores. So the dependent variable is the variable that we are measuring, that we want to assess the effect of the independent variable. So that would be their reading scores. That is the final effect that I'm looking for. So let's do that in green. So that would be the dependent variable in green, like that. How about controlled variables? Controlled variables mean anything else that could influence my dependent variable. So what else could influence my reading scores that we want to keep the same? We don't want it to influence your reading scores in this example. So a couple of things I could think of, what else could influence your reading scores? Maybe the amount of time that the students sleep. That could influence their reading score. But I'm going to keep that constant because in this experiment, all I'm interested in studying is I'm interested in only looking at the effect of TV time. Okay? So I'm going to keep the amount of time they sleep constant so that it doesn't play into my results. Another thing I could maybe keep constant is how will their reading scores be assessed. So I gotta assess all my students the same way, otherwise it would not be a fair comparison, okay? So I'm gonna keep that as one of my control variables. How their reading scores will be assessed. and so on. I could have other controls variables. I could have maybe the diet they eat. If somebody is eating really healthy food and somebody else is not, or maybe they're not getting enough food, you know, that could definitely influence their reading scores, and that I don't want that to play into my results. The only thing I'm interested in this problem is the amount of time they spend watching TV and how that affects their reading scores, okay? So once we have this, how do we form a hypothesis? So I'm going to write it right here. To form a hypothesis, you need to have three things. You need to mention the independent variable, you need to mention the dependent variable, and you need to make a prediction. Make a prediction as to their relationship. So what will happen to one as you change the other? For example, here we got IV, independent variable, amount of time spent watching TV. Dependent variable, we said, is their reading scores. So my hypothesis could be something like this. And we can write this in an if-then format or not. It's up to you. That's optional. But I'm going to use the if-then format. If the amount of time that fourth graders spend watching TV increases, then their reading scores will increase. All right, so here's what I've done with my hypothesis. I have mentioned my independent variable right here. That is clearly part of my hypothesis. I have mentioned my dependent variable, the reading scores. So that is part of my hypothesis. And I have made a prediction as to how one will affect the other. Okay? So my prediction was that the amount of time, if the amount of time increases, let's do that in red, I said that their scores will also increase. My hypothesis would also have been correct if I had said, for example, this also, I'm just going to copy and paste. Here's another valid hypothesis I could have had. If the amount of time that fourth graders spend watching TV increases, then their reading scores will decrease. That is also a valid hypothesis because it is a prediction I'm making, and I'm going to use my experiment to test this hypothesis. So I'm going to design an experiment that's going to test if my hypothesis is correct or not. So your prediction, what I'm looking for when you guys write a hypothesis, is that it includes these three things. It must include the independent variable, must include the dependent variable, and it must include a prediction. So you cannot just simply say the amount of time spent watching TV will influence reading scores, because you have not made a prediction on that. You have just told me what we already think we know that it's going to influence, but you got to tell me how will it influence those scores. All right, let's do another one together. Does the amount, actually let's go to this one. Does airplane design, so does how aerodynamic an airplane is, affect the distance it flies? So what would be, I'm going to do my first thing, I'm going to identify my independent variable, which is going to be how aerodynamic the airplane is. That's what's changing in the experiment. So how aerodynamic an airplane is. That's my independent. Dependent variable. What is the effect that I'm trying to measure? The distance that the plane flies. So the distance the plane flies. All right. what are some things that I may want to keep the same in this experiment because I don't want them to influence my result? I'm only interested in the aerodynamic design of a plane. Well, maybe I want to keep the same pilot flying the plane. How about the same amount of fuel I want to keep, okay? And so on. There are many things that you could keep constant and you should control as variables if you are truly interested in only measuring how the aerodynamic design of a plane is affecting the distance it flies. Now let's make a hypothesis. So like we said before, in the hypothesis, we must include the independent variable. We must include the dependent variable. And we must make a prediction. So let's use the if-then format again and say if the independent variable, which is aerodynamic design of a plane, improves, then we're going to make a prediction to what happens to the dependent variable. Then the distance the plane flies will increase. All right, so I have everything I need in my hypothesis. I have my independent variable, I have my dependent variable, and I have a concrete prediction. I'm not just saying if one changes, the other one will change. I'm actually saying how it will change. If the design improves, the distance will increase. All right. Let's do one more. Does the strength of fertilizer used affect the growth of bean plants? All right, my first question was my independent variable. What is it that I am purposely changing in this experiment? Strength of fertilizer. So I'm going to write that down. Independent variable. Strength of fertilizer. Dependent variable. What is it that I am measuring? The effect of that strength of fertilizer on what? I'm measuring the growth of bean plants. So the growth of bean plants I'm measuring. What do I want to control that could also have an effect on growth of bean plants, but I don't want it to come into play in this scenario? Well, maybe I want to control, make sure that all my plants that I'm testing get the same amount of sunlight. I'm going to want to make sure that they get the same amount of water, that maybe they get the same humidity, the same soil, the same a lot of other things, okay? We got to keep constant. Going back to my hypothesis here, I got to have my three things in it. My independent variable, my dependent, and a prediction of how one affects the other. So I'm going to do if my independent variable, the strength of fertilizer, I'm going to say decreases. Then my dependent variable, the growth of bean plants, will decrease. All right, I mentioned my independent variable, I have my dependent variable, growth, and I made a very exact, very precise prediction. Okay, I said if one decreases, the other one will decrease. It's something that I can go and measure in my experiment and actually get some data on. All right, I hope this helped you with hypotheses. Just make sure you got those three things in your hypothesis and you should be all set. Your independent variable, dependent variable, and a prediction as to what happens to one when you change the other. I'll see you guys in class.